Alright, hello everyone, and let's continue building our application for personal finance assistance. We called it last time. In our last session, we started to sketch out the system design, architecture of the system, and the roadmap. And today we will go a little bit deeper into the architecture. If we review the the design, this is the repository we created last time, and here we have the architecture overview. I have already, before this session, I have already updated and cleaned up the design spec. Let's see what I've done. No, not this. I wanna check the diff. Okay, so I just cleaned up unnecessary separators, redundant headers, and I also added a couple of questions. Let's have a look. Yeah, I formatted the the file listing, cleaned up. I also the deletion mode, it was in TODO, but we have already decided that it will be a tombstone strategy. We will not delete records permanently, we will just mark them as deleted, and we will keep them in the database until garbage collection is implemented and run. Okay, minor updates here. Our IDs will be 4 characters with a prefix, and the characters will be from this range, which means that all Latin alphabet, English alphabet letters plus digits. That will give us 14 million records already, which will be more than enough for a single user. I have added TODO to migration strategy. Migration strategy is something that we will need to look into, maybe today, maybe in one of the next session. We'll see, depending on the time. I added this TODO. We will we will think a little bit about backwards compatibility with the saved data. Formatted file listing. Okay, this flow, synchronization flow, doesn't have manifest JSON updated, and this is also very important because manifest JSON is the cornerstone of the sync process. Okay, this one is cleaned up. MVP, file listing updated. Okay, improved the section titles a little bit, and added one TODO. It's important for us that we make sure that PWA actually works on iOS. Maybe we'll run a little experiment. We'll see. This is another thing that we'll need to explore. Okay, so I will commit update, minor update, design MD, minor clean up, and added TODOs, commit and push. And now we will use this Ctrl A, Ctrl C. I copy all this, and we will use this to start our next ChatGPT session. So I will create a project first. I could have done it last time, but I can do it this time as well. We will not lose anything. BudgetClick-2026. Creating project, and let's start a new chat. Okay, first of all, let's give ChatGPT our current design. Okay, I'm building an app. Here is the design. Highlight gaps, TODOs, and give me your suggestions. Give me your suggestions for better design given my goals and considerations. Boom. Okay, let it think a little bit. That's a very strong MVP architecture. The biggest strength is that you've been disciplined about what not to build. That's good. An offline first, encrypted, user-owned storage architecture without any backend is surprisingly achievable today. My biggest recommendation is to think less about finance app and more about a local database that synchronizes encrypted documents. Most future flexibility comes from getting the storage, sync, and identity model right. Here's what stands out. Overall assessment: Advaita current design approximately, simplicity 10 of 10, cost 10 of 10, privacy 9 of 10, offline first 10 of 10, future extensibility 8.5 of 10, sync robustness 6 of 10, security completeness 6 of 10, data model 8 of 10. The weakest parts are exactly where you'd expect: synchronization, encryption, metadata, versioning, conflict handling. Those will determine whether the app feels reliable. Biggest architectural gap: the manifest. Right now, manifest JSON is almost undefined. That's good. In reality, this will become the heart of synchronization. I'd make it something like, okay, manifest missing storage version for the data. You have schema version for the data. I would separate schema version from storage version because these evolve independently. Example: schema version, storage version. Storage version changes when encryption changes, chunk format changes, compression changes. Schema changes when record gains a field, category changes. Those should never be coupled. Object format: every encrypted object should probably have a common wrapper. Instead of encrypted blob, I'd define version object type nonce ciphertext, or header encrypted payload authentication tag. This makes future upgrades much easier. Encryption to do. This section needs much more detail. Questions still unanswered. AES GCM blah blah blah, random salt, object authentication. Okay, so to-dos, manifest, sync strategy, data schema, storage schema, envelope, encryption, IOS feasibility with PWA, zero cost, no setup. Key hierarchy. Currently there is only encryption key. I'd strongly recommend an hierarchy. Key hierarchy, encryption key. Okay, encryption we will need to go deeper into that. Manifest encryption. Should the manifest be encrypted? Should the manifest be encrypted? Yes, it must be encrypted, since S3 bucket is public. Everything should be encrypted, and file names obfuscated, except for date, monthly chunks, question mark. Okay, if encrypted, okay, manifest will be encrypted. I would encrypt almost everything except maybe a bootstrapped object. Yeah, this is the same what I've just written. Chunk metadata. Each chunk should contain metadata. Example, schema version account. Chunk metadata. Storage schema envelope. Chunk metadata. Keep with the chunk or in the manifest. That's the question. What is migration? How is it related to the migration? Migration, we need to look into migration, especially connection, especially relation, local as versus storage relation. Backward compatibility. Good. Synchronization. This is where the design needs the most work. Sync strategy. This is the first in my list. First item in my list. How do you know someone else didn't upload first? You need optimistic concurrency. Something like download metadata, conflict resolution. Okay, that's part of the sync strategy. Conflicts resolution. Merge by default. Later iterations, manual resolution, maybe. Conflict resolution, merge records, three-way merge with her local change log. Okay, local change log, no need to design. This will be implemented easy way during MVP stage. Client ID currently absent. Yes, client ID. This is a setup client ID. Yes, client ID. Client ID is generated during setup. Yeah, this is a must. this is a must for null for client resolution for conflict resolution. Makes sense to keep that in the record. Resolution. Good. Record model current amount description expense ID. I'd avoid expense ID, instead category ID. Okay. Category ID approved. Change it. Transaction type in out. I think you'll regret this. Interesting. I instead define transaction type income expense transfer adjustment. I'd instead define transaction type in out flag agree. Keep both fields income outcome. What is transaction type? Explain your fields. Okay. Good. All right. Explain those fields. Currency, account currency. Can one account ever contain multiple currencies? Probably no. Good. But records should probably still store currency exchange rate because future imports become much easier. Okay. Record. Currency and exchange rate. Yes. Currency. Good. Exchange rate. Exchange rate. Comparing to what? Comparing to what? I think that it will be. I think that this will not be ever needed because account has currency and all spends will be from an account. Exchange between accounts is just another operation consisting of two records in and out from both accounts. balance. You currently store current amount. I would avoid storing derived state instead. Opening balance, transactions, balance. Otherwise synchronization bugs become harder. Balance, agree. Keep balance, keep the current balance in the storage. Maybe in the future this will reduce calculations. Because we load only current date plus minus 50 records. Okay, we will not be able to calculate the balance real time. We will need to keep the balance in the storage, because we will not be able to do this. We will not be able to calculate the current balance because we don't have the data. The data will be in the storage. There might be data for 10, 15, 20, 50 years, and we will not load all this data to the client. So delete, attachments, huge missing topic, question, compression, image resizing, okay. Attachments, S3 layout. Okay, shard, attachments, big topic, omit for now. Reference data, current reference data, use accounts, chunk, categories, chunk, contractors, chunk, using the same storage format as transaction chunks. So it suggests using chunk instead of JSON. Why chunk and not JSON for reference data? Maybe because it will be an encrypted blob. Maybe. Let's see what it says. Statistics at asks, should statistics exist remotely? They're derived. Personally, I'd remove them. Every client can compute them. Statistics cannot be computed on the client because client has only current transactions with infinite scroll in UI. So it has, oh, interesting, yeah, statistics, so it has to be calculated, has to be calculated once and saved, then updated, probably like this, updated on data change. Another big topic, omit for now, just save these considerations. Good. IndexedDB, yeah, IndexedDB, another big topic. Omit for now, just good. SyncQ, object hashes, compression, search, worth, planning now. Should search work? Offline, yes. Data is cached on the client side. Keep that in mind. 2. Audit fields. Created at, updated at, yes. Created at, updated at, yes. IDs currently 14, but collision become on because IDs are permanent. Let's simply use, okay, no problem. IDs we can increase the length to 8. Missing document. I think you're missing an important design document. I would create storage object specification for every object defined, file name, schema, encrypted, compressed version, migration, life cycle, updated frequency. This document becomes the contract for your storage layer. Contract for your storage layer. Interesting. Why? IS. Cached passphrase. I would never store the passphrase itself. Instead, store S3 configuration in IndexedDB. Optionally use the browser credential store to require the user to re-enter the passphrase after the app is closed, depending on the chosen security level. Consider offering a remember on this device option that protects a locally wrapped encryption key. This provides a better balance between convenience and things to add to the to-do list. High priority. Define encryption specification. Design manifest structure and lifecycle. Define optimistic sync protocol and conflict detection. Specify chunk metadata and version. Define IndexedDB schema in indices. Create a storage object specification. Medium priority. Client ID generation. Compression strategy. Attachment lifecycle metadata, data integrity verification, hashes, checksums, object sharding, large attachment collection, derived data strategy, whether statistics are stored or recomputed. Low priority. Undo history support, optional key rotation, optional encrypted backups, snapshot, future support for shared multi-user vaults. One larger architectural suggestion: instead of treating S3 as files the app uploads, think of it as a replicated encrypted object store. Every object, manifest, reference, data, master, chunks, and attachments should share the same life cycle. Serialize. 1. Serialize a typed object. 2. Compress, optional. 3. Encrypt. 4. Compute a content hash. 5. Upload with version metadata. 6. Reference it from the manifest. Using a uniform pipeline reduces special cases, simplifies migrations, and makes future features like version history snapshots or alternative storage providers much easier to add without changing the core architecture. Good. Okay. Nice. Update your to-do list. Keep it brief and focused. Good. That will be enough for now. Next step, we will update the documentation. Okay, let's see. I think we're converging on a solid MVP. I also like that you're intentionally pushing some topics out of scope. This will keep the architecture manageable. A few comments on your decision list. Transaction type, I will replace in-out with direction or cash flow and add transaction type. For example, TypeScript direction in-out, transaction type income expense transfer adjustment, income expense transfer adjustment. Direction answers, does money enter or leave this account? Okay. Okay. Transaction type. Keep direction. No need for transaction type. Premature complete. This is a premature complication. Next, currency. Good. Chunk metadata. I would keep minimum inside every chunk. For example, okay. Chunk metadata. Accepted. Next. Storage contract. Why storage contract? This is one document I absolutely keep. Think of it as the API specification, but for storage. For every object defined, path, purpose, encrypted, schema, migration rule, lifestyle, ownership. Okay. Storage contract. Agree. Created. Updated TODO. Update TODO. Given those decisions, I'd simplify the MVP further. Keeping only direction is the right trade-off for now. Transaction that doesn't solve any current requirement and can always be introduced later. True. Updated TODO. Okay, core architecture, highest priority, manifest, synchronization, data schema, storage format, chunk format, encryption, migration, client setup, ISPWA feasibility, core data model, documentation, storage contract. Okay, good. Update README with these considerations. Update roadmap with these to-dos. Create storage contract MD. Is it Markdown or maybe JSON or maybe YAML? I think it should be Markdown, and I will give it the design MD current roadmap MD current roadmap. Good. Now let's wait for ChatGPT to create these documents. Okay, I would make one structural change before updating the docs. Instead of letting design MD become the place for every technical detail, I'd keep it as the architectural overview and split implementation contracts into separate documents. Design, architecture and principle, roadmap, storage contract, data schema, sync, encryption, migration. Okay. Struct docs accepted. Docs structure accepted. Provide full code for each document. Now let's create new folder, docs, and move these files. Move, commit, refactor, docs. Next, waiting. That's exactly the direction I would take. One small addition before doc. Okay. This keeps each document focused. Okay, doesn't change anything. Okay, that's new storage contract. Markdown. New file storage contract. Markdown. Okay, this is a placeholder. Good. What else do we have? Would not provide the full contents in a single response. Good. A better approach. Okay. Okay. Agree. Give me the docs one by one. It says that it cannot provide all the documents in one response because it will be too long for one ChatGPT response, and instead it suggests giving the code for the documents one by one, one document per one response. So that's design, markdown. Good. Okay, what did it do? Oh man, it has rewritten it completely. No, I don't like that. But do not rewrite. Only minimal changes to the document. Okay, it agrees. Rewriting the document was the wrong approach. Now it tries to give me changes, which is again bad strategy. So I will update my request. I'll update my prompt. Provide full code of updated design. Design.md. Because the current is longer. Oh man. Okay. It says that the document is too long. Security model. Okay, update security model. Good. Okay, then let's do it one by one. One section after another. Security model. All right, we have completed all the updates. We have here the diffs. So we have updated the design markdown. Here are the changes. We updated the security model. So we've done all the changes we have just discussed with ChatGPT. We have added data schema. Here is how it looks like. Data schema, purpose, design principles, blah blah blah. We will review it later. we added the encryption document. Encryption, here how it looks like. Purpose, design principles. Maybe we will clean it up because those sections are not really needed. We don't need it. Security assumption, encryption scope, key hierarchy. Okay, migrations. Also, there is a document for migrations. This is how it looks like. Again, we have the purpose, design principles, schema version, storage version. Okay, we'll address this later. Roadmap is updated as well. Roadmap is updated as well. It's not updated how I wanted it to be updated. I like the to-do list which ChatGPT gave me earlier, but okay. Final design, storage contract, data schema, sync, encryption, migration. Well, probably storage contract includes manifest. Let's have a look. Storage contract. Purpose, again, okay, we don't need the define storage layout, storage object responsibility, object lifecycle. Okay, let's keep it for now. The document intentionally does not define synchronization protocol, encryption algorithm, data schemas, data specified separately. Design principles, storage follows these principles. Every object is encrypted, every object is self-describing, every object is independently versioned, objects are immutable between downloads and uploads. Storage is considered untrusted. Storage contains no plain text user data. That's correct. All objects are encrypted before upload. This is correct. And we have the manifest here. Storage object life cycle, storage objects manifest. Purpose, owner, update frequency, contains. Additional metadata may be introduced in future versions. Does not contain financial records, attachment contents, decrypted metadata, reference objects. Reference objects store relatively static entities. Examples: owner, reference objects, monthly chunks, does not statistics, owner, attachments, object version. Okay, let's check synchronization document, sync.md, preview. Again, purpose, defines synchronizes data, design principles, that's good. Synchronization unit, account plus months, changing a record affects only the monthly chunk, that's true. Reference data is synchronized independently. Synchronization responsibilities, the synchronization engine is responsible for downloading, uploading, conflicts, merge, manifest update, keeping local storage consistent. The synchronization engine is not responsible for encryption, migration, business rules, local workflow, user action, update local database, update current balance, mark object dirty, continue working. The application never waits for synchronization. Synchronization flow, detect dirty objects, download manifest, synchronization, compare versions, download remote objects if needed, merge, serialize, encrypt, upload, update manifest, synchronization complete. Okay, design MD, record description is actual currency ID, amount, account ID. Do we need to keep the account balance after each with each final account balance with each transaction record. It might be necessary because we cannot calculate the final amount. At the same time, I would like the transaction list show the resulting balance. It thinks it's not good to store the resulting balance with every transaction because yeah, I agree that it can be become the source of subtle bugs. Option 1, store balance on every record. Balance. If you insert a transaction okay, let's keep it simple for now. No changes are needed. Keep the account balance and updates will, and the record balance will be backward computed from the balance. Okay, if an old record is updated, the account balance will be updated accordingly. Good. Yeah, the roosters agree with me. Right. Okay, so no changes to the record are needed. Good. Okay, so now let's go back to our to-do. So this is our updated to-do. Let's copy it somewhere. For example, in yeah. Oh well, let's commit this. Update docs and add new docs. And now let's add a temporary file. Okay, so let's see what it suggests about to do. Core architecture, highest priority. Manifest, encrypted structure, synchronization lifecycle, chunk reference metadata. Okay, now let's okay, so this will be all for now, and the next step will go deeper into manifest. Thank you very much, and see you in the next episode.